this is very controversial, but my view is that philosophy is a science, but it's not a natural science. So let me explain what I mean by that. When we're talking about natural sciences, we're talking about things like physics, chemistry, biology, which are involved in the study of nature, and where doing experiments and carrying out observations by microscopes and telescopes and so on is a big part of the methodology. Although philosophy has all kinds of interconnections with the natural sciences, it's not itself a natural science. It does very little in the way of carrying out its own experiments. And I think that is why quite a lot of people are very reluctant to call it a science. But we have to remember that not all sciences are like that. And the most obvious example of one that isn't is mathematics, which is just as rigorous as the natural sciences. But it's not a natural science. It doesn't proceed by doing experiments at all. Not because because mathematicians are too lazy to do experiments, but simply because they would not be relevant for what they're doing. In the case of philosophy, it's not that there's any ban on experiments in philosophy, but on the whole, the experiments that are relevant to philosophy are done within related subjects like psychology, and then philosophers, when they need to, can take account of them. For example, if you're doing the philosophy of perception, you're studying the nature of sight and hearing and smell and so on. The philosophers of perception will typically take account of what the psychological evidence from experimentation is about. So that it's not that that's irrelevant to what they're doing at all, but the experiments are best done by the scientists. And a new aspect of methodology which has come in mainly over the last 50 years is the use of simplified mathematical models to understand what's going on in all sorts of very complex situations. So in many areas of science, for example, in lots of biology, you can't really produce accurate predictions of what's going to happen, let's say about the evolution of certain species or something like that, because there are far too many factors to enable prediction to take place. But you can still understand a lot by building mathematical models which simplify the situation but show certain kind of structural aspects of what's going on in a way that makes it much clearer what some of the underlying processes are. For example, biologists might consider a model of reproduction by 3 sexes rather than 2 to see why it is that the norm for reproduction in most species is with 2 sexes. And it turns out that kind of model building methodology works in philosophy as well, and quite a lot of it is done, for example, in epistemology, which is the theory of knowledge. It turns out that by building simplified models of, for example, of different kinds of uncertainty, like the uncertainty involving a lottery, we can use those models to understand all sorts of structural aspects of the way that knowledge works or doesn't work.